What are the important bits to understand about the ocean? Well, mostly a lot of it is going to be currents. We talked about currents back in climate. Hopefully that should have given you a hint that it was going to be important here too. When we have currents, they're driven by differences in density. So what are some things that can actually change the density of seawater? Some of it is just temperature. The farther up, the closer to the surface you are, the warmer it's probably going to be. The closer you get, or the further down in depth you get to the bottom, the colder it's going to be. A rapid change in temperature in seawater is called a thermocline. But if we don't see a rapid change in temperature, if it's the exact same, kilometers and kilometers down, we call that an isothermal. So temperature is going to be a big thing, but you could already figure that out. You know that the further down in the water you go, the colder it gets. What else changes it? Well, pressure, but you should remember pressure, hopefully, from weather. The more pressurized it gets, it changes the density. You go back closer to the surface and it doesn't have that hydrostatic pressure on it, then it's going to have a lower density. Lastly, the thing you hadn't talked about before, but hopefully you will remember now, is that an increase in salinity is also going to increase the density. So all those things are going to be important because the density then changes the vertical position of the water. Well, what does that mean? It means the same thing we've talked about since week 1. Less dense stuff is on top, more dense stuff is on the bottom. All those factors, just like in weather, are constantly working with each other and constantly changing the density and just kind of figuring out where does water need to go. So how does this really affect the currents and why are the currents important? Well, without the currents as we know them and without the conveyor belt of the currents as we understand them, climate on Earth would not be what we expect it to be. It's not what we're used to. We take warm water at the equator because it's the most direct sunlight from the sun, and it really, really warms, at least at the surface, the water up. These warm currents then flow for us specifically past North America and Europe, and it takes warm water up closer to the poles. As it moves the warm water, it's influencing the climates of these places. A quarter of all heat on the Earth is transferred by these oceanic currents. But eventually, once it gets to the poles, it starts to mix with that cold water, and it starts to just get colder because there's less direct sunlight. Well, the more, the temperature drops, the more dense it becomes. The more dense it becomes, the closer to the bottom it gets. Well, it's eventually going to hit a cold current, and that cold current is going to take the water eventually all the way back to the equator. Now, it might take a bit of a trip before it gets there. It's not just going to, directly beeline for the equator. But as it warms up, it becomes less dense. As the salinity changes, it becomes less dense. We see a rapid change in temperature. It's called a thermocline, but sometimes we see a rapid change in density, and that's called a pycnocline. So, if I gave you a graph of that, I would ask, where might you see this on the Earth if the temperature doesn't change that much, but the density does due to salinity changes? Maybe the answer is closer to the poles. Constant movement from the warm water to the poles to the cold water back to the equator is called the conveyor belt of oceanic currents. It's all driven by differences in density, and it's what helps regulate and transfer heat throughout the entire world. It's what helps regulate climate. Without these oceanic currents, we wouldn't have them as we know them. But what about the other currents that you might have seen at the beach, the surface level ones? Those are driven by wind. And surface currents driven by wind can't go that far because the wind can only push it so much. But you remember the pressure gradients from weather and how much that impacts how strong the winds are. So now you can kind of see how all of this stuff is starting to tie together. Well, what else do we need to know about oceans? Well, there's different, parts of the ocean, but overall oceans make up about 72% of Earth's surface. We can see that mid-Atlantic ridges are forming. We go back to lithosphere, and that's where new seafloor is made. We also see a lot of geologic activity, which helps influence what's going on at depth there. You can hopefully start to understand why the order of the units was the way it was, because this is all kind of starting to build on itself in hydrosphere in our next unit, that is biosphere. But we don't just need to talk about climates, and we don't just need to talk about the density cycles. We need to talk about what happens at shorelines. For us in North Carolina, our beaches make us a lot of money. It's not just pretty and it's not just fun to visit, but it makes us economically pretty viable. So we have to take care of our shorelines, and we have all sorts of different currents and events and weathering and erosion that happens there. Longshore currents are when the waves go in an angle and they pull back straight out, and then they go in at an angle and then the waves pull it back. Eventually, that's going to cause different types of erosion. What do we have to do? Well, we have to fix that in order to protect it. What else do we need to do? Well, we have to make sure that we are taking care of the beaches, and sometimes we have to build things called jetties or groins. Jetties are in pairs and they keep waterways open, like inlets or bays or harbors or something like that. It lets ships and boats and stuff, maybe rivers, it lets things get through them. Groins are on beaches and they help try to prevent the sand from washing down the beach. We can also build things like breakwaters and seawalls and mangrove forests and all sorts of stuff like this to keep the waves from having such an impact on the coastline. Now, before you were born, because the beaches were eroding so badly, Cape Hatteras actually had to be moved over a mile inland, otherwise the lighthouse was going to fall into the ocean. Now, this isn't anybody's specific fault, but it's still something that we have to take care of. It's still something that places have to, keep an eye on, especially the forest and interior departments near the beach. Also, what you see, and if you're at the beach and maybe you're staying at a beach house and you have to walk down the boardwalk to the sand, is that there's dunes down there. And the dunes have the grasses and shrubs and reeds and stuff like that in them. Well, all of that is supposed to help keep the sand in place too. If we keep that up and we maintain that and we go out and we dredge and we renourish the beaches with sands and stuff like that, then hopefully we're going to keep our shorelines in better condition. We're not going to see as much weathering and erosion, specifically erosion by ocean currents, meaning like waves and stuff, not the ocean currents we talked about that move all the climates and all that stuff around. And we can start to understand what's going on better so that we can maybe get better mitigation techniques as we move forward. Now, of course, there's a lot more that we could talk about with oceans and why they're important, but that's the big stuff. That's the things I'm going to highlight. That's the stuff I really need you to know. Hopefully it helps.